Hello, this is Chemistry, Central Science 11th edition, and we are in the end of the chapter questions of chapter 3, and we're in question number 11. Balance the following equations. All right, so we have carbon dioxide, gaseous oxygen, carbon monoxide plus oxygen yields carbon dioxide. I'd like you to do oxygens and hydrogens last. And so in this case, I will start with carbons. I've got one carbon on the left, one carbon on the right, so that's okay. Now on the left, I've got 3 oxygens. On the right, I have 2. Now, since I have 2 oxygens on the right, no matter what number I use as a coefficient, I'm always going to have an even number. If I use an even number, it'll be even. If I use an odd number, it'll still be even because I'm multiplying something by 2. So in order to fix this, I need the left side to always be even. As long as they're both even, then I can finagle them to where that they will both have the same coefficient. So since O2 is always even, I'm going to go ahead and put a 2 right there, which will give me 2 oxygens. It's messed up the carbons a little bit, so now I have 2 carbons. I'm going to come on this side and have 2 of those. So now my carbons are okay, 2 carbons, 2 carbons. I've got 2 times 2 is 4 oxygens on the right, and then I come over to the other side, I have 2 plus 2, and that's fine. So it's going to be 2 plus 1 oxygen yields 2 carbon dioxides. Okay, next one, B. I'm going to do hydrogens and oxygens last. So I'm going to start over with the nitrogen. I have N2 on the left. All right, so I'm going to double the hydrogen here, or the nitric acid here, so I can end up with 2 nitrogens. Right, so let's do oxygens next. On the right, I've got 6 oxygens, and on the left, I have 6 oxygens. Hey, I think that's fine. So let's check again. 2 nitrogens, 2 nitrogens. 5 plus 1 is 6. 2 times 3 is 6. Oxygen's great. Okay, so let's look at hydrogens. 2 hydrogens on the left, 2 on the right. That's all we took. Okay, not bad. Now let's do C. I have methane gas plus chlorine gas yields carbon tetrachloride plus hydrogen or hydrochloric acid. All right, so let's do hydrogens last. So I'm going to start with carbons. I have 1 carbon on the left, 1 carbon on the right. So carbons are okay. Chlorine, I'm going to have 2 on the left, and I'm going to have 5 on the right. Now this reminds me of the odd even thing. Since I have Cl2 on the left, I need to make sure my chlorines are always even. Now the Cl4 is even, but the HCl is not. So I'm going to come over here and double it. Okay, now I might have to double a double or triple a double, but I need to at least double it. This gives me now 4 plus 2, so there's 6. I have 6, and 2 times 3 is 6. Okay, now let's see if what that has done, because do you see, by doing something, you're always messing something else up. So you always have to start again and check again. So I've got carbon and carbon. That's good. Okay. Then I've got 4 plus 2 chlorines on the right. 3 times 2 chlorines on the left. That's 6 chlorines, 6 chlorines. That's good. 1 carbon, 1 carbon. Okay, so let's look at hydrogens. I've got 4 hydrogens on the left and 2 hydrogens on the right. So no, I need to double it again. Okay, so I'm going to strike this. This becomes a 4. And now I've got 4 chlorines plus fluorochlorines is 8. So I've got 4 chlorines on the right, 2 times 4 on the left. And so your answer then is going to be 1, 4 yields 1, 4. 1 methane, 4 chlorine gas yields 1 carbon tetrachloride plus 4 hydrochloric acid. You see, it's a back and forth, back and forth, back and forth. All right, next one. Wow, I've got a carbide. Interesting. Aluminum carbide plus water yields aluminum hydroxide plus methane gas. All right, so let's start with the aluminum. I've got 4 on the left, so I'm going to come over here and do 4 on the right. All right, let's go ahead and do carbons next. I've got 3 carbons on the left, so I'm going to come over here and do 3 carbons on the right. All right, so we're going to have to separate them into hydrogens and oxygens. So let's do oxygens. 4 times 3 is 12. Okay. So I need 12 oxygens. So that means I'm going to have 12 waters because there's 1 oxygen in each. Now let's see what happens to my hydrogens. 2 times 12 is 24. Okay. I've got 3 hydrogens times 4 is 12, plus 3 times 4 is 12. 12 and 12 is 24. Yeah, there it is. So it's 1, 12, 4, 3. All right, E. Okay, let's start with carbon. There's 5 carbons on the left, and so we're going to write 5 on the right. Let's do hydrogen next. I've got 10 on the left and 2 times 5 on the right. I just had a red flag here because if you look at the oxygens, on the left I've got a 2 in the first molecule, I've got a 2 in the oxygen gas. Those are both even. On the right, carbon dioxide is even, so no matter what number I multiply, that's going to be even. But the water, since there's 1 oxygen, if I have an odd number in front of it, it's not even. That means in order to make the oxygens the same on both sides, they have to both be even. So I'm going to double this to 10. All right? By making 10, then I've got an even number on both sides, and eventually I can get the numbers right. If one side is odd and the other's even, it doesn't matter what numbers that you multiply it with. You can never get everything. You're always just going to keep multiplying forever. So I double that 5 to 10, but I've messed up my hydrogens, and so now I have 10 times 2 is 20, so I have to come back over here and do 2. Okay, well that messes up my carbons. I have 2 times 5 is 10, so that means that has to be 10. All right, so I now have how many oxygens on the right? 2 times 10 is 20, plus 10 more is 30. I have 30 oxygens. How many in the first molecule? 2 times 2 is 4. All right, that means I have 26 more oxygens on the left. So that's 2 times 13 is 26. So it'll be 2, 13, 10, and 10. That was a hard one. Okay, F. I've got iron and iron. I've got 1 on the left, 2 on the right. So I have to double that one. Let's see if I can keep sulfates together. Okay, I've got 1 sulfate on the left. I've got 3 sulfates on the right. So I'm going to go ahead and multiply that by 3. So now let's look at hydrogens. Okay, I've got in the first one 3 hydrogens in the hydroxide times 2, so there's 6 hydrogens. I'm just going to write myself a note. There's 6 hydrogens here. 2 times 3 is 6 hydrogens there. So I need 12. So that's going to be a 6 on this side. 2 times 6 is 12. All right, now let's look at oxygens. On the left, now I'm not counting these oxygens because those are sulfates and I've already taken care of it. So I'm just looking at the first ones. This is 3 oxygens times 2, so I have 6 oxygens on that side and 6 oxygens on that side, so it looks good. So it'll be 2, 3, 1, and 6. Nice. Last one. Magnesiums, I have 3 on the left, so I'm going to have 3 on the right. Okay. That was a big bug that just flew into my reading lamp. How about that? Alright, so I've got 3 on the left, 3 on the right. Good. Let's see if I can keep my sulfates together. Alright, now I have 3 sulfates, so I'm going to do 3 on that side, sulfates. Let's do nitrogens. Okay, nitrogens, I have 2 on the left and 2 on the right. Good. Alright, so what else do I have? I'm going to do hydrogens. 2 times 3 on the left. 2 times 3 is 6 on the left, and 2 times 4 is 8 on the right. Okay, so that means I'm going to have to finagle just a bit. Okay, so let's see. I had 3 of those. Ah, there's 4 of those. Look, there was 3 of those and 4, so I need a 4 here. Okay. Let's see if that takes care of it. Magnesiums, I have 3 magnesiums. I have 4 sulfates, 3 plus 1 sulfates. I have 2 nitrogens, 2 nitrogens, and I have 2 times 4, 8 hydrogens on the left, and 4 times 2, 8 hydrogens on the right. Very good. So it's going to be 1 to 4 to 3 to 1. Okay. All right, long one.